We just have to turn it off afterwards.
Yeah, sure. Cool. Awesome. Cool. Hi everyone. Happy to see you all back here. Some of you back, some new faces as well. So welcome to the 5th Apache Beam meetup here in London. Just a quick shout out to a lot of people this time. So Qubit for everything you're drinking and eating, for the venue as well. Datatonic for setting up and sponsoring this meetup. Talend for bringing JB over here and sponsoring his talk. And Google for sponsoring Ruben's talk and some of the swag, which you might get later. So quick update from the community. Still, if you want to tweet about anything that's happening here, feel free to use the hashtag Apache Beam London. If you want to stay in the loop, sign up for the mailing lists and maybe check out the Slack channel as well. If you want to give me and Victor some feedback, you can fill out the survey and tell us if you like it or not, what you want to see, if you want to have crazy things happening, I don't know. Some other thing I want to highlight is the Beam Summit. So we're thinking about doing a Beam Summit in Europe as well. We had one earlier in San Francisco in March. So if you want to be part of this, if you want to present something, if you think our company has an interesting use case I want to share with everyone and this could be useful, check out the mailing list or hit me up and then we can talk about it. I want to highlight that these meetups are recorded as well, so if you can make it at any point, you can check out the YouTube channel now. So I hope you guys still want to come for beer and pizza and talking to other people, but in case you can make it, check out the YouTube channel. And then there's another initiative from Griselda. She is making the Beam newsletter, so if you want to put something in the Beam newsletter, like a blog post from your company, some news or anything else, or you just want to check it out about the latest things, that's a good summary of what's been happening in the Beam community. So, on to what's happening tonight. We have JB and Ruben obviously over. JB will be talking about some use cases he took all the way from France, from Talend. And then Ruben will take the stage and he will talk about the Beam roadmap and some new features in there. So yeah, that's pretty much all I wanted to say, and I'm happy to give the stage to JB. And there will be interesting questions, and if you have good answers or good questions, you might win a t-shirt. It's all up to these guys.
All right, good evening. So last time I came here, I give a talk about IOs, deep dive, and splittable Dufen and all that stuff. This time is not as technical as before, just to show you usage of Beam that you can do, putting a tool on top of Beam. So we're going to compare some use cases. If you have to do that directly using your IDE or your code and using a tool that we provide. So a couple of words, just the most important is I'm a member of the Apache Software Foundation. I'm PMC on Beam. I was the lucky mentor during the incubation phase of Beam. And on the other hand, I also fellow at Talend, so that's why I'm here today. So the first thing is we're going to compare Apache Beam and DataStream. So DataStream is the tooling that we put on top of Beam. What's basically the difference? The second part will be how you start with Beam and how you start with DataStream. What's the difference? And I pick up 4 use cases. Maybe they are not so good. I don't know. You will let me know. The first use case is data ingestion. The second use case is IoT normalization. So normalization is I have a data on one form, and I would like to convert in another form because I would like to populate my data lake or whatever. And the latest is analytics. So Beam, I guess you already know what Beam is. So I just extracted the the key words. So unified prime model, designed to provide efficient and portable data processing pipeline. Okay, so whatever the SDK you're going to use, the model will provide this. And on the other hand, data streams. So data stream is a web tooling on top of Beam. So instead of writing directly your Beam pipeline using Python or Java, whatever, you design directly using a browser your pipeline, and we create the code for you. So when you have to start your Beam project, what you have to do is first you decide and you make a choice on the SDK. So shall we start with Java or Python or whatever? For the use cases and the examples, I use Java SDK. Okay, but it's basically the same if you use Python or another. Once you have decided the SDK, the first thing you have to create is a project. So the project containing your pipelines. So if you use the Java SDK, the first thing you have to create is a maiden POM. In the POM, you define the dependencies. So the first dependency is the SDK dependencies. Second thing is the IOs that you're going to use in your pipeline. So you want to connect with Kafka and HDFS or whatever. So you have to define these dependencies. Maybe other dependencies you need, like logging using SLR4j or log4j or whatever. And finally, the runner dependencies, because you remember Beam does not provide the execution engine itself, so you have to pick up a runner that will execute the pipeline. And once you have created this project, you actually execute the pipeline on the execution engine. So most of the time, leveraging the tools provided by the execution engine. If you use Spark, you use Spark Summit. If you use Flink, you use the dashboard or the command line, whatever. The same using this time data stream. You just create an Amazon image. So we provide an image. You bootstrap your AMI, so Amazon machine image, and you start on Amazon. And you have a data stream ready to use. Okay? So if you use on Amazon, most of the time I'm using Spark, it's already plugged, so you just can execute. If you want to use data flow, you will see that in data stream you can select the runners you want to use. So this is an example of a small project that I created. So here you can see the dependency to SDK. You have a dependency for an IO, which is a HBase in that case, and a dependency to SLR4j. Nothing special there. And finally, I created a profile to execute using the direct runner in that case. In terms of skeleton, most of the time what I'm doing is creating one pipeline per class. It's not my preference. You can create multiple if you want. The same most of the time is executed in the main. There are no requirements. You can wrap into another execution method if you want. And in the main or in your method, what you're going to use is do is create the pipeline. So using the pipeline options. Define the steps of your pipeline, so the chain of P transforms, and finally execute the pipeline. Okay. If you use data streams, is a little bit different. The first thing you're gonna create is all what we name the inventory. So inventory is basically all the connection you're gonna use in your pipeline. So I don't know, JDBC connection, HDFS connection. So where is your master name node, all that stuff. And you can also define some data set. So data set is a subset of data. So it's not the data itself, it's the form of the data, the schema if you want. Okay, it's not exactly a schema, as Roman will introduce just after, but it looks like a schema. Finally, using this, you design your pipeline. It goes into what we name the stream runner. So it's a kind of abstract runner that we created. And we leverage another Apache project, which is named Apache Levy, if some of you knows. Levy is really responsible of converting the data stream runner code into the target execution engine. So the runner will be translated there. So we build the pipeline there, and we execute on data flow, on Spark, on Flink, or wherever. So it looks like this. So here, this is a connection. So you can see I created a connection to an SQL server, so to extract the data. And here I can create the data set. So basically the data set is the data that I'm going to extract from this database. And I define the schema. Okay. So let's start with the first use case, data ingestion. Basically, it's I would like to retrieve some data from somewhere. So most of the time a database or HBase or whatever, and ingest into the data into my storage. The old name was data lake, but you give the name what you want. So I don't know, maybe HDFS, maybe another HBase or another database. Most of the time it runs in batch mode. So it's not streaming mode. It's I execute every 2 times a day or every night or whatever. It uses bounded source IOs for the one who already knows Beam. So it means that I extract from a bounded IO. And the example I'm going to use for this one is I would like to extract data from JDBC and put into my HDFS storage. So I use JDBC IO to retrieve the data from a database. And I use text IO to populate my HDFS. In addition, I use a p-transform to group the data, just to format the data. It doesn't really matter. So the code is like this. Maybe you already know that. So I create my pipeline. I use a JDBC IO with a data source configuration. So this is a daily data source for the example. I provide the query and the row mapper. So the mapper is responsible of converting each row's result set into something that populates the P collection. So here in my case, I provide a KV of string, and the coder corresponds to this. And finally, I use a pardo of a doFun where I create a grouping of each key in the KV. So each key will be grouped, and I will have a key value of string and iterable. Okay? And at the end, I use text.io to write on HDFS. So this is all that the code that you have to do to populate the HDFS. Exactly the same thing using data stream. So I consume from the database. So this database has been created in the inventory as I showed before. I use a Python row, so you can use a Python to create some kind of function. So the grouping function is done by a small Python code. It's here, pretty simple. And at the end, I do an ingestion. When I define this, I can execute on different runners. So this is the profile here. So you have a drop-down. So exactly the same code you can run on Dataflow or switch to Flink without changing anything. Without recompiling or anything, just click on the launch button and it's executed. Second use case, IoT. It's pretty the same. The main difference is this time we react for each message we're going to have on the backend system. So for instance, Kafka, MQTT, MQP, or whatever. So this time we are in streaming mode. So my pipeline never stops. It's always active. So I use a embodied source. For this example, I use Kafka IO. So I'm going to consume from a Kafka broker. The message on Kafka can come from different devices or other systems like Apache Camel. And at the end, I use exactly the same. I use text.io to store on HDFS. But this time, the data comes from Kafka. So the same, this time I use a Kafka IO. I provide the bootstrap servers from Kafka, the topic, the key, and value deserializer. And I do such kind of grouping, like a value string. So I created a string containing the content of a message that I get from Kafka. This time I'm in streaming mode, so to generate the result, I have to use a window. Okay, so I create a window every, I compute the data every 30 seconds. Okay? And at the end, I use the same text.io with HDFS. Okay, so basically the same, but in streaming mode that time. And the same, but using data stream. So this time you can see I don't have database, I have Kafka.io. Okay. This side, the HDFS, is basically the same. The main difference is in the middle, you have a 30-second window. Okay? And the definition of the window is there. So you can define the window duration, the window slide length, etc. All beyond the hood, the code generated will be exactly the same as you do by hand. Okay? Another use case is normalization. This time I consume streaming or batch, it doesn't really matter. I receive or consume data from somewhere. This data use a type. Let's say it's Avro, it's an XML, it's a JSON, whatever. And I would like to convert this data into something, a kind of canonical format, common to my system. So in that, this time, I use batch streaming, it doesn't really matter. The difference is where the data comes from. But I'm going to use some special IOs that don't consume from somewhere or write, just convert from a data to another. So Avro IO, XML IO, JSON IO. These IOs are available directly in Beam. So for this example, I use JMS IO, so in streaming mode, to retrieve data and receive message coming from an ActiveMQ broker. And the message uses XML. Okay? The message format is XML. And I would like to convert this XML into a JSON. And the purpose is to send into an Elasticsearch. So I'm going to use a transform to convert my XML into a POJO, and another one to convert POJO as a JSON. It could be optimized using a single one, just for the example to split the details. And finally, I'm going to use the Elasticsearch IO to send my JSON into Elasticsearch. So pretty simple for the JMS IO. I just provide the connection factory with a queue in that case. So I receive the data from ActiveMQ. And after that, I use a Pardue that convert using JAXB. So you take the XML and create a POJO using a JAXB. So you can see I start from a JMS report there. So this is the object provided by the JMS IO. And I convert into a biography. So biography is my own POJO that containing my JAXB annotation. I create the JAXB context in the add setup. So to avoid to recreate the JAXB context for any element in the key collection. And here you can see I directly convert. So I get the payload from the JMS record, which is a string, and I use a marshal to convert from XML to POJO. On the other hand, I use Jackson. So I have a POJO. I would like to convert my biography POJO into a string, but this string will be a JSON. In that case, I use a mapper. So mapper is a Jackson object mapper. And at the end, I use Elasticsearch IO with the string that I converted into JSON. Okay? So there are a lot of optimization that we can do there, but the example is really to show that we can convert to custom POJO that you can create. The same using data stream is even simple because here you can define the schema there and you can define the schema there. And the conversion will be done by data stream. All the code that I show you, you can create it for you. Okay? Thanks to the schema. Last example and use case is analytics. So this time is a batch of streaming. It doesn't really matter again, but we're going to use a lot of different p-transform and function to group or do history or sum or whatever. So in that case, I read data from HDFS, I change several p-transform, and I create HDFS for the result. My example is pretty stupid. It doesn't really matter. You already know how to do that. So I read from HDFS, and I read a CSV file from HDFS. I use a do fun just to process each row in my CSV file, splitting using the comma. I extract only one part of each row in my CSV file. And after that, I do some computation to have the number of data with each row. So the first part of a row is the key, and I have a lot of data after, and I would like to count the number of rows using the same key. And finally, I use HDFS to write to TextIO to write to HDFS. Sorry. Exactly the same this time using data stream. So I read from the database or HDFS. I do a function which is aggregate in that case, and I write to HDFS. Okay, so the only thing you have to define is drag and drop using your browser, the boxes, and define the P transform that you want here. So here you do a new element. The element is basically the P transform you want, and here you can define, depending on the P transform you're going to use, you can define the operation, the field you want to extract. That's the introduction of data stream. So just to let you know that data stream has been released 2 weeks ago, I think. It's something that we are working for more than a year now. That's why we are committed to Beam since the beginning, I think, at least for me. So the purpose is really, we don't want to be honest, I'm Beam developer, so I prefer to use code. But for a large part of Talend customers, they don't care about the code. The only thing they want to do is to extract the data, to execute the data, and to be able to run on different execution engines. So that's why we created the data stream tooling. Maybe some of you know Talend. Since the creation of Talend, the purpose is really to democratize the usage of language like Apache Camel, Apache Beam. So data stream is really the idea is really to simplify the way for non-technical people to use Beam. We are also you can also define the pipeline using data stream, and in these pipelines you can use some data prep function that has been created in Talend data prep. So there are some bridges between the Talend products. Do you have any questions? Yes?
So is there a version that runs just on the laptop without reliance on AWS, just for developers?
Right now, there are no way to run on premise. That's a decision of Talend. There are no technical limitations. It's just a question of business. So no, the only way right now to use data stream is really to run on AWS.
And your roadmap is then to extend to other cloud providers soonish, or?
Theoretically, no.
Okay.
We want to data stream is really cloud focused. So we started with AWS, but if tomorrow we can find some way to run directly on Dataflow or Dataproc or all the provider, we're gonna do that. But on premise, no. That's the marketing decision, I would say. Yes.
So most of the examples are the bounded data sources, a function, so my question is in two parts. If on the bounded part, you're going to have a more complex case, you've got side inputs because you're broadcasting data. I want the output to come out using tuple tags. I'm going to send one of the tuple tag outputs to a secondary pipeline. Do you support that?
Yes, so the side inputs are already supported. So you can do a lookup in a P transform where you want to join some kind of data coming from your main bounded source plus additional. This is supported. For the output, is not in the first version. Is not yet supported. We plan for the next release.
So you could change using tuple tags.
Yes.
To secondary pipeline.
Right.
And on the second part, will this extend to fixed window and session window?
Absolutely, it's already supported. You can define fixed window, sliding window, and user window.
You've got examples on
I don't have here, but yes, for sure. I know this is an example with a fixed window in the slides, and I think I have another one with a sliding window. I don't have any user window for now, but yeah, it's supported for sure. And you can also extend data stream with your own component. So for example, in the box, in the palette that we provide, you have created your own I/O using splittable DoFun, for instance, or you created your own DoFun. You can load this in data stream and directly use it in the pipeline.
So in that context, we use a lot of pipeline options to abstract the input providers and the writers so that the functional programming part remains the same, and you can plug in and plug out
Right.
the IOs, right? So
Right.
what do I do? Do I supply my own pipeline options and you will leverage that, or is that back to hand coding?
Is back to, yeah, for now you have to load a special option.
Yeah.
So you have a pipeline option and
It's the register, right?
yes, exactly. Is you know, in the first part of when you do all the data set there and connection, so in the pipelines there, or for one pipeline you can provide your own pipeline options. So what we are doing is a pipeline.create with options. So basically you can hook with your own code there. It's possible. The idea is really to be simple to use, but we want to give you some hook to inject your own logic. For example, we have a bunch of users that they have created their own DoFun. And they don't want to re-implement all the DoFun using a Python wrapper that you created. So what we are doing is, if you have the DoFun, you package your DoFun in a jar, and you load into data stream, and you just, so when you do the register, you give a name to the DoFun. So it's basically the map containing name DoFun, and when you use this, you just do a DoFun execute, and you give the name of the DoFun, and you're gonna use it. Yes.
I want to start the other way around. Can I use this to create a skeleton and then get the code?
No.
Yeah.
No way. No, yeah, that's the classic question. Can I use this to create code that I can? No, and for two reasons. The first reason is politics. No, and technically it's because of this one here. Actually, we don't directly generate the Beam code. We build the pipeline. That's a little bit different because the code is really built there in this row. And when you are in the data stream in your browser, you are there. So actually, this part, it's where we actually generate the code. And the code is generated just before the execution of the execution engine. So we never generate the code in the window, the browser window. So that's a little bit different. And to be honest, no, we kill our business if we do that. Yes.
So how would you integrate this with a delivery pipeline like CI/CD? Once you do changes, if you want to redo your change or add stuff to it or add new.
In that case, so when you
transforms.
click here, where is it? So here, basically, when I click there, I delegate to a job server, if you want. So something running on Amazon that we control. So if you change something in this pipeline, injecting your new DoFun, whatever, you will have a notification there saying, be careful, you have changed the pipeline, it's not the one executed, so you have to refresh. In that case, you have to stop the pipeline and re-execute. Like you do using Spark Summit if you want. Okay, you have your Spark Summit running, and you change something in the pipeline, you have to bootstrap again. Exactly the same. Okay? Something that I didn't mention, but which is pretty cool, you see here the plus icon there. If you click there, there are a small direct runner running in the, not in the browser, but in the backend. And here you can have some sampling of your data. So here you can see the data coming. So instead, it's not really reading the complete backend, but here you can see, okay, from Kafka, this is the sampling of the free message that I got. And actually the tooling use this to try to detect the schema you're gonna use. Okay? So the plus here use a direct runner embedded but just to show you the sampling of the data. And you can see there, so you can see the difference between the sample there and the sample there. So if you do some big transform, you can see the conversion from one type to another.
So on AWS, you're doing Flink as the runner?
Yeah.
So how do I say how many task managers, what is the job?
This
what's
is-
the topology that I control?
Yeah, this is here on the profile. So the profile could be generic for any pipeline, or it could be specific to one pipeline. And here is all the pipeline options you can pass to a runner.
But,
You know,
but in Flink, you will have to, generally you use scripting, Ansible, or whatever you choose to use to bring up your tasks and your job manager and all that.
we don't provide the Flink execution engine.
Okay.
Okay? We just do as you do when you are using Flink. You have a dashboard, and once you have created your jar file using Beam, you just do on the dashboard upload and you customize your stuff. It's exactly the same there.
Because you start interfering with the scalability. So I'll be very curious to see how it works in Dataflow, because you start interfering with the auto scaling and all the other decisions that Dataflow makes for you as a runner. Right? So
But as you do today using Beam, if you use Beam as code, you create Beam and you do execute on Dataflow. Okay? Here you can imagine exactly the same. The Dataflow, you just specify where Dataflow is, and we just bootstrap and execute on Dataflow. Nothing changed there. You see what I mean? It doesn't replace the execution engine. It just replaces the code that you're gonna write. Okay? So in terms of Flink or Spark, because it's basically the same, all the tuning you can do on the Spark cluster or the Flink cluster is still on your scope. Okay? We don't interact with we interact with the execution engine, but we don't customize or we don't change anything on the execution engine.
there's a slight deployment difference in Flink. You build a Uber jar. In Dataflow, you give your individual jars, right? So this is where I was confused.
Yeah, but the difference is there. That's why we're using Livy.
Okay.
Livy provides a REST API that can run with any backend. So, for instance, when I bootstrap using Livy on Spark, I know that I created an Uber jar. If I run Flink, I know that I create something different. And this part, that's why I have a bin job at this level. This part is delegated to Livy. Okay, so for the data stream, the only thing he knows is the REST API of the Livy server. And all the jar generation and packaging and all that stuff is delegated to Livy. That's why I'm Livy PMC as well.
Nice.
Is there any way to version control your pipeline?
What do you mean?
So you deploy like something you make in the UI, and then a week after you make a little change to your like a certain transform.
So here you have two choices in the profile. You can execute a new pipeline. For data stream, it's the same in terms of design, but you change something, so you can leave the existing one running and bootstrap a new one. Or you can stop the old one and deploy the new one. When you do a change on an existing pipeline, then the data stream will ask you, what do you want to do? You want to override the existing one, so you stop and redeploy, or bootstrap a new one. So in that case, it can consume from the same data source. It's up to you know if it's what you expect or not. So but tuning asks you. Most of the time, you undeploy and deploy.
Is this a multi-user environment, or you have like VM for one person and that's it, like a single dashboard?
You mean for
Yeah, for the streams. If I want to, if I'm part of a team, do we have to start like a new VM for each user? Or
No, it depends on the execution engine that you're going to use. Data stream only use one VM if you want. Livy is another VM. Actually, I have multiple VM for Livy. The registry control, this one, it's where we decide if we bootstrap a new version or not. It's here. And here, I have only one for all users.
Yeah, so everyone connecting to the same machine.
Exactly.
Like exactly the same thing.
Right, that's why it's on Amazon. So you can have 20 users connected to, they are actually connected on the same data stream instance. Once one is editing a pipeline, another one can only view, it cannot change, there's some kind of log. And when you bootstrap, you decide what you're going to do. We use Git behind the hood. There are some Git repo embedded.
So you mentioned in the beginning it's for free. What's the constraint on that?
That's a good question. No, the idea is really to, all that I show you will stay free. The only difference is there are some connectors that you may have to pay. Connectors, they are not technical connectors, it's more business connectors. Let me take a concrete example. You want to connect with Salesforce. The Salesforce connector for data stream will be in an enterprise edition. But all the technical connectors, maybe you know that we created a lot of IOs in Beam. One of the main reasons is for data stream. No, because honestly, I mean, it's a community effort, but the first contribution of Talend in Beam at the beginning was really the IOs, because if data streams doesn't have IOs, it doesn't make sense. So that's why we started with that. So there are some connectors that will be in the paid offer. But the overall architecture will stay free.
And there's no limit on scaling identifiers
No.
because it's separate.
No.
Okay.
It depends on the execution engine after. But for data stream itself, no, there are no limitations. No other question? Thank you. Yes,
Thanks, JB, for that great presentation. So actually, when Beam first started, it started off as a Dataflow API, and the people working on that Dataflow API decided to make it open source under Apache, and none of them knew anything about how Apache worked, how the process worked, and JB was the guy who came and mentored the whole project, helped teach people, here's how Apache works, here's the Apache process, and shepherded the whole project through that incubation period into what Beam is now. So.
Sorry, I forgot to move forward.
Oh, no problem. All right, so I'm going to focus now a little bit more on Beam itself, and I'm going to talk about some of the roadmap of Beam. Starting off with usability improvements. So one message that we've heard a lot from users of Beam is that Beam is really, really powerful. We can solve all sorts of problems with that, but Beam, especially Beam Java, is a little cumbersome to use. The best quote I remember hearing was, simple things can be hard to do in Beam, but hard things are surprisingly easy to do in Beam. And it was one of those things where the model was powerful and flexible enough that things that this person thought would be impossible to do, he was able to do in a few lines of code, but then doing the really, really simple thing just got bogged down with all the extra boilerplate he had to write to do it. So, one of the challenges with simplification is you want to simplify without sacrificing power. So you often see when people want to simplify APIs like this, say, oh, let's do a simplified API, and you end up targeting a much narrower use case and you sacrifice the power of that API. So we want to simplify Beam, but not at the expense of making Beam less expressive. And then I'm also going to talk a little bit about the portability story and where we are with Beam portability across runners and languages. One thing that I didn't have on the slide that is worth mentioning, because I think two people asked along this line of question, is lifecycle management for pipelines, especially for streaming pipelines. So we have a proposal out for Beam about snapshots and updates. So there's a proposal to build an integrated way to snapshot a running pipeline, get back, some sort of URN that identifies that snapshots. And you can have a whole bunch of snapshots. Then you can start a new pipeline from a snapshot. So that will be a way, for instance, to update a pipeline is take a snapshot, stop the old pipeline, and then start a new pipeline from the snapshot. And you can modify the snapshot. You can say, I want to change the types. Run a transform over that snapshot to change all the types from integers to strings, get a new snapshot, and start from there. Also do things like canary a pipeline. Create a snapshot, start a pipeline, run it for an hour, and make sure it looks good. So we have a proposal out around that, although that wasn't part of the slides that I was going to present today. So the first thing I'll mention, and this is actually something that we already have in Beam and will be going out with this upcoming 2.5 release, is about new do-fun. So if any of you use the old Dataflow API before Beam, one of the differences between Dataflow and Beam was this process element method. So in Dataflow, do-fun had the base do-fun class had a virtual method called process element. You overrode it, and it took one parameter called process context, and that was how you got everything. In Beam, everything is injected. So process here is not a virtual method. It's just you put this process element tag in front of the annotation in front of a method, and Beam just finds that method and says that's my process method. And if you give sort of the right parameters to the method, Beam actually just finds those parameters and injects them. So process context here is just Beam finds that parameter. It can be anywhere in the parameter list. Like if I had 5 parameters, process context could be in the middle, the end, the beginning. Beam would just find it and inject the right process context. And you can use it for things like, what is the current window of my element? We'll just add another parameter to your process method, and Beam will say, oh, you wanted the window, I'll fill it in. However, this do-fun injection stuff was never fully finished in Beam. So the idea was to be able to inject everything as a parameter. But a few things got implemented, window was one of them, and then the rest ended up in this process context, which is just a big bag of every other parameter you might want to use. So usually you always do process context, and people are always doing c.output of c.element. Well, as of this upcoming release, more things can now be injected. So, for instance, I can just create a parameter to my process element method and say, this is my element. Tag it with that element. Give it that type. If the type doesn't match, by the way, you'll get an error when you try to run your pipeline saying you asked for an element that didn't match the input type of your do-fun. So actually what it means is some type checking is moving from compile time to when you actually first run your pipeline. Same thing for outputting. You can add a parameter of type output receiver, and now I don't need process context anywhere in this do-fun. I can just make it all normal parameters to my process method. This doesn't actually do anything to decrease the amount of code you have to write, but the hope is we can make these things much more readable. So instead of this big bag object you get in, you can just make them nice parameters to your method and know what they are. Also, if you have multiple outputs from your do-fun with tuple tags, you can just, instead of output receiver, you can create a multi-output receiver, and that gives you an interface that lets you output to multiple tuple tags from your process method. So the full list of things that can be injected, it will be in the Beam documentation, but most of them are here. You can inject the element. If you want another timestamp of an element, well, just add an instant and tag it with timestamp. Interval window already was there. Pane info, if you are triggering a window multiple times, pane info is what gives you information of this is the 15th trigger of this window, and it's an early trigger or a late trigger. Output receiver and multi-output receiver. Essentially, the reason why some of these have these annotations and some not, the ones that are internal Beam types, so output receiver is an internal Beam type. So if you make it a parameter, we assume that's what you want. Anything that's a user type or a public type, you have to annotate. For instance, your do-fun might be taking instance. So then we would need a way of knowing which instance is supposed to be the element and which instance is supposed to be the timestamp of the element. So anything that's a public type, you give an annotation saying, no, this is meant to be the element or the timestamp. We still don't have everything, so we haven't completely limited process context yet, but I think it'll come. So the biggest thing that's not yet supported is side inputs. Side inputs, you still need process context. We would like to support side inputs and have, maybe have each side input just hooked up as a parameter to your method. So if you have a map side input, just create a map parameter to your method and annotate it and say, this parameter should be hooked up to this side input. But we're not quite there yet. And process context still exists, of course, because it would be a backwards incompatible change to get rid of it. So it's still your choice if you want to use process context or if you want to use this more, the explicit way of getting stuff out of the element.
Sorry, can I just?
Yes.
So this you can completely eliminate process context if you want to, but it's an optional parameter.
Yeah. So as I said, we can right now except for do funds that use side inputs, you don't need process context at all anymore.
So we get a lot of our pipeline options with the process context.
Oh, pipeline option is also a parameter.
Okay,
If you add it, sorry, I didn't put it here, but if you add pipeline option, so that actually already existed, but it wasn't well documented. So if you add a parameter of type pipeline options, Beam will just fill in the pipeline options thing. All right, so those are the changes around new do fund. I'm going to talk about schemas next, which is going to be the bulk of my presentation. And this is actually interesting because it's more of a fundamental extension to the Beam model. So traditionally the Beam model it's a record processing system, batch and streaming, and records are blobs. Users provide coders to tell Beam. Users are allowed to write their do funds in terms of their actual type. Users don't have to deserialize binary blobs, and users provide coders to say, here's how to deserialize it. But from the perspective of Beam, a record is just a binary blob. Beam has no knowledge of what's inside this blob. But it turns out if Beam had some knowledge of how this blob was structured, there's a lot of things you can do that would be both simpler for the user and also more efficient in many cases. And it turns out that if you look at the types of records people use, 90% of cases, this is a type of record where you can define a schema on it. It's fields of a small number of primitive types, especially if you allow these schemas to be recursive. So one of the fields could be another row with another schema. Most of the time, users' records actually can conform to this. Whether people are using POJOs or AVROs or protocol buffers, all these things are things that you can put a schema on top of. So we've been spending the past number of months exploring this and seeing how far we can go down this direction of adding schemas on P collections. One thing we wanted to do is we did not want to make it an either or. So it's actually very nice that you can create your custom type and have your do fund process that type. So we didn't want to create a system where we create a row object and you either decide to process your type or you decide to process row objects, but they don't work. We wanted something where things work seamlessly together and you could process things as your custom type without having to give up the benefit of having a schema on that type. All right, so what is a schema? At a very simple level, a schema is a mapping of a name to a field. Actually, it's a name and an index to a field because you can access the schema by index or by name. And what is a field? A field is either some very primitive type, a byte, an int, a float, a double, different, also, int 16, int 32, int 64, different size ints, a date time. Or a field can be recursive. A field could be a row which itself contains a schema. So you can have a schema that contains a schema that contains another schema. Or it can be a collection of fields. So a field could be an array of byte. It could be a map of string to byte. Or it can be an array of row. So you can have a recursive schema where you have a list of different nested types. So essentially, this is a tabular data structure, a semi-tabular data structure. It's not precisely a tabular data structure in the traditional database way, simply because of this recursive structure. But it actually, the way a lot of databases such as BigQuery work, or even Calcite, this is this is how rows are usually defined, as these sort of recursive structures. So you can think of it as a denormalized form of what you would have in a traditional database. In a traditional database, everything is normalized. You wouldn't have recursive rows because that row would just reference another table, which would reference another table. This is kind of a denormalized form of that. So let's look at an actual example. So here I've created two POJOs. The first one is a log entry. My log entry for my fake system that generates logs contains a user ID, geolocation of where the log entry was generated, so a lat long, and a list of events that correspond to this log entry. And every event contains an event type, which here is a long, maybe it would actually be some sort of enumeration, and date time, here I think I meant it to be a JOTA date time, but a date time containing the timestamp of that log. So really easy to create a schema for that. It's just user ID and latitude, and it looks like I actually forgot longitude in my schema, but pretend there was longitude there. And then an events entry, which is an array of event schema. An event schema has an event time and a date time. So, and this is, the thing you see on the left is what you see a lot of people doing with Beam. Either whether they do it with POJOs or Avros or JSONs or protocol buffers. And it's very easy to just generate a schema corresponding to that. Okay, so requisite warning ahead of time. I'm gonna show APIs here. Some of these APIs are in Beam already. They're all marked experimental, which means the Beam community may well decide to change them. So you're welcome to play around with them. But when you upgrade Beam, you might find the APIs have changed a little bit, and you have to change your code. And some of the APIs you'll show at the end have actually not been written yet, so are quite likely to be a little bit different from what I'm showing here. Some of them are more, the ones at the end will be more aspirational. So how do I set a schema? So the model we came up with is that a schema is a property of a P collection. So the type of the element today is property of a P collection. So similarly, a schema is essentially a form of type. So a schema is a property of a P collection. So we've added a method to P collection called withSchema. By the way, this is currently in a branch, and there's a pending pull request to get this all into master. So within the next week or two, this will be in master. So I can, read from some source unspecified here, and just call .withSchema, pass in my schema, and there we go. There's a schema on my P collection. And then I can just apply the rest of my pipeline and do whatever I want to do with schemas. This is useful in a lot of cases, but it's actually not a very satisfying way to do schemas for large pipelines. Because if you've ever written a large pipeline, you have a lot of P collections. And you don't really want to have to take your entire pipeline and just go everywhere and go, okay, .withSchema, 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 .withSchema on every P collection. So, one of the things we spent some time thinking about is how can we make it simpler to just make schemas just work without having forcing a user to create a P collection. Well, the first thing you can do is register a schema for a type. So, P here is the pipeline object. Pipeline object now has a schema registry class, and you can register a schema for a class or for a type descriptor, and just say, here is the type, here is the schema for this type. You have to give a little bit more information, basically, here's how to access the fields from the type. So that, you can either give a function saying here's how to convert the type to a row, or a set of getters. Or you could say that my type is a bean. Some things are going to be well known. If my type is like a Java bean type and it has getters on it, you could say it's a Java bean. Just understand how that works. Now I don't have to set the schema, because anytime I have a P collection of that type, Beam can just know, hey, I know what the schema is for that type. So here I've created two branches of the pipeline where with this previous way of doing it would have been a little bit cumbersome. I would have had to do .withSchema on both branches. Now, since I've registered that type, Beam just knows what the schema is. But we can do even better. A lot of cases we can statically infer what the schema is. So one example is these POJOs. Beam at graph construction time can do a reflection analysis of this POJO and figure out the structure of it. In fact, Beam already does that for, if you've ever used the Avro coder. It's exactly, we support creating an Avro coder for any POJO. It's the same thing here. So there's a schema provider class where you can write a provider that knows how to provide schemas for any object. We plan on providing some built-in ones, so the most obvious one is going to be for POJOs. Just put this annotation on your class, and Beam will look at the class and say, okay, yeah, I know what the schema is for this class. So here, this is basically that log entry there, although I didn't write the recursive thing, but I did in the previous one, although you could. And now, if I have a P collection of that type, I don't even need to go to that extra step of figuring out the schema and calling register. Beam just knows what the type is. We can do similar things for, say, an Avro, something coming from Avro, or something coming you're reading from a database. Okay, we know what the schema is for the database. You have JSON objects. You can write providers for all these things, with the hope being that you get to the point that you still might have to do this registration if you're using some very custom type, but for most common types, Beam should just be able to look at it and know what the schema is. Another common use case is people have external stores where they store schemas for their objects. So, for instance, Kafka has this. There's a Kafka metadata schema store that people use. People use things based off of Hive. So that's another use case for the schema provider object, is you can write a schema provider that when you look up a schema for a type, makes a call out to this external system and says, what is the schema for that type? And then the organization can update that storage offline and say, okay, here's a new type, here's a new schema, and it'll just work. Schema provider, this is all done at the graph construction time, so you're not while the job is running, you're not going to be constantly hitting it. It's going to happen once when the graph is being constructed. Okay, so a lot about what a schema is and how you can register a schema. How do schemas actually help? So how is a schema actually going to make life simpler for a Beam user? Well, the first obvious thing is we can provide a set of library transforms that do a bunch of common things on anything with a schema. So, for instance, I just threw a few here that you might do. Read long entry from filter from your source. I don't want internal users to be part of my analysis. Well, filter.fields user ID. You can put multiple fields there. Pass in a lambda saying filter out everything that's not a user ID. Okay, I want to project down. I don't want to. It turns out my log entry contains 100 other fields other than user ID, latitude, and longitude. So I can, just apply a select here and say, okay, just select these three fields. Now maybe I want to count. And by the way, these transforms don't exist yet, so this is where I'm sort of inventing the syntax right now, so these things might change. So here maybe I want to combine by the user ID field and say for every geographical region, an S2 cell is basically a way of chopping up the sphere into little geographical regions. For every user ID, I want to see for every S2 cell, I want to see how many unique user IDs are in there. Just do that. And now write back to async. So this is code that actually you could totally write today. You don't need schemas for this, but everything would just take so much more time to do. And actually, it shouldn't be surprising that this looks very much like SQL, because one of the things that gives SQL its power and lets SQL do the things it does is that SQL always operates on tabular data. So this is almost like a programmatic version of what you could do in SQL. Or another example, joins are notoriously cumbersome to do in Beam today. Beam provides this code group by key API, which is extremely low-level join API, and there's also side input joins, and people tend to write a lot of code trying to get their joins done. But, once you have schemas, there's a very natural way of saying how to join. You say join, say I want to join by these fields. Maybe I want to join these fields on the left side with these fields on the right side. Give it some options, saying what type of join you want to do. And now you have a join P collection. And again, this should look very much like SQL, because that's how you do things in SQL as well. You select a certain number of fields from 2 tables. You tell it which fields to join by. And maybe you give some other stuff like a where clause. And speaking of SQL, another use case is making Beam SQL easier to use. So I think there was a previous meetup where Beam SQL was discussed, but it would be nice to be able to do Beam today with Beam SQL. You have to give it rows. There's this row object, so you have to take your data, run a Pardue, try to convert all your data into this row object that has a schema to it basically, and then say apply Beam SQL to it. But as I said, one of the goals is that schemas should not stop you from operating on your data type, this log entry data type. And here it doesn't anymore. So if log entry has a schema, you can just pass it directly to Beam SQL, and Beam SQL says, okay, you have a schema for this thing, I can just run a SQL statement on it. And you actually end up having 2 ways of doing things. You can either start doing things, some people prefer doing things programmatically, some people prefer doing things with SQL. And there are advantages and disadvantages to both. Some people find SQL easier to use. It's sometimes easier to, if you're programmatically generating your pipeline, it's sometimes a lot easier to do that, this way than to generate a textual SQL, expression in code. Okay, so, there'll be a bunch of built-in transforms. There'll be SQL. There are all these ways to use schemas. What if you want to use a schema in your own Pardue? So it turns out that none of these built-in transforms are giving you exactly what you want. So the way that will work, so I already mentioned, you can create a do fun and say, out element and give me a log entry. The same thing will work with schemas. So I can just say, in my process function, instead of asking for a log entry, say ask for a row object, which is this object that has getters for column names. And Beam will automatically first verify the log entry has a schema, because otherwise you can't convert it to a row. And if it does, it will just automatically convert it to a row and give you a row instead. And so now you can write a do fun, and it's your choice. You can either operate on a log entry or operate on a row, and the only difference is what type you put in that element. And the same for the output receiver. I could, if I wanted to, I could get things as rows and output them as log entries, or I can get them as rows and output them as rows, and that will only work if the output P collection also has a schema, and Beam will verify these things and just do the conversions for you. And actually, you can do a little bit better than that if you know ahead of time which fields of the schema you're going to access in your do fun. Well, then you can just say, hey, I'm actually accessing 3 fields in the do fun, user ID, latitude, longitude. Just create parameters in your process method for those, and Beam will be able to just unpack those fields for you, and you don't have to deal with this row object. Different use cases. A lot of, for instance, the generic transforms like select, you don't know when you write it which fields people will access because they're generic, so transforms like that will have to operate on rows. But if you're writing a custom do fun for your business case, often you do know I'm only accessing these 3 fields, and you could do something like this, and Beam will just unpack that for you. And we can also, to be honest, we can also do that for some of our existing types, like KVs. We can also do an @key @value, and we may do something like that. Also going to extend a lot of this to common sources and syncs. So, for instance, if you're reading arrows from Kafka.io, plan is to be able to just have that for the schema. Depending on what you're reading, either you have the schema, or if you're just getting generic records, there are strategies where you can, I sample records from from the source, sample 10, 20, 30, and infer a schema from that and try that. Transform the data, and then write it back up to say BigQuery IO here. And notice, if you've ever used BigQuery IO before in Beam, usually you have to specify the BigQuery schema, and you have like this much code to specify the schema. Notice you don't have to do that anymore, because BigQuery IO will see that the input P collection is a schema, and just knows how to turn that into a BigQuery schema. So it'll make using a lot of these sources and sinks, especially the ones that are database related, much, much simpler, because there'll be conversions between these different types of schemas. And this is something that I just threw together, but like an example of if you want to enable a completely different library. Let's say you want something called data frames. So how many people here are familiar with data frames? So data frames is a library. I think it started off with the R programming language that was focused on statistical analysis. It became popular in Python through a library called Pandas. And then later Apache Spark adopted it as part of their API. But it's an API that's very focused on dealing with this sort of tabular data. I could create a data flow class that wrapped a P collection, and it contains all these fluent APIs. So I just threw this together, but in here I create this data flow class around a P collection, say group by some column, summarize, and then in summarize, what I'm giving it is, here's a field, and here is a function that I want to use to aggregate that field, and I can give multiple fields. This thing will keep creating new schemas every time I do that. So I'll have a group schema for the slot. I'll have these new fields in the output schema of total clicks and total revenue. And then after the summarization, maybe I'll say, okay, give me back the P collection that's a result, and write it to whatever destination I want. So like an API like this would actually be trivial to write. Like once we have all these these helper transforms and schemas, you could probably write this data frame API, which will contain more than summarize in a few days. I cheated a little bit here, so like of course in Java you don't use brace syntax like that. It would be a lot of immutable list.of, but I didn't want to fill up the slide too much. And so this is somewhere we want to go. We want writing a Beam pipeline to often be as easy as this, but without giving up. Even with this API, you never give up power, because whenever you want to, I can do .get P collection, whatever I can do in Beam today. Any fancy window function, any function combiner, any fancy site input, and then I can also wrap it with a data frame again and keep using this nice fluent data frame API. And finally, complaint we've always seen is that coders are complicated, and semantics of coders aren't clear. You notice that none of these pipelines I've shown so far have coders, because if you have a schema, there's the framework can come up with a default and efficient way of encoding a schema. What that is still to be. So there's a current coder for schemas. That's a custom one. We may decide to use something like flat buffers or Apache Arrow or something. That's still, to be determined. But the point is that users don't have to make this decision. They just say, here's a schema, and the framework will try to come up with an efficient encoding for it. And the efficient encoding might also be one to enable optimization. So if you're projecting, if you're only accessing 2 fields of a schema, it might be an encoding that lets the framework only decode those 2 fields without having to decode the entire record. Whereas today you have to always encode and decode entire records in Apache Beam. So that's what I had to say about schemas. A little bit about languages. Python and Go. So Python's been out there for a while. As soon as 2.50 is out, which is JB actually has a current release candidate for 2.50, so with any luck, that release candidate is the final one, and in a few days we'll have a Beam release. Historically, usually it takes more than one release candidate, but it shouldn't be very long now. Python has full-fledged streaming support using the new portability API. So Python streaming in the past was kind of a, red-headed stepchild, but now it's, first-class citizen. Go, So if anybody's interested in using Go, Beam Go is now an official part of the Apache Beam repo, and also supports both batch and streaming. And Beam Go is written completely on the new portability API. And finally, these are some things we've in the Beam community came up with. But realistically, a lot of the stuff that's hard to use from Beam has to come from users of Beam. Sometimes we're a little bit spoiled knowing how Beam works too well, so we don't always realize what's hard because we just know how it works. So please, 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 if you have ideas or if you just have things that you're like, this sucks, I had to write 50 lines of code to do this one simple thing, please let us know. I mean, you can let us know here. The Beam development list or the Beam user list are also both great places to say, as a user or a developer on Beam, here's what I found difficult. And maybe, if you have ideas for how to make it better, please include those ideas. We've talked about more higher layers on top of P collection. There's already one called Shio, which is a Scala-based API, which is used in some areas. Fluent methods on P collection. Some people want more than P collection dot apply. They would like to just be able to do P collection dot, whatever. Kind of like I showed with that data frame API. Any of these ideas are up for discussion. All right, so that's it on usability. I will talk. Whoa, what happened to the rest of my slides?
Did you copy them over to the?
Oh, was this copied?
This was, yeah.
Oh, I didn't realize it was a different slide deck.
You can, is it?
Okay.
You can look your.
Okay, I'm going to switch slides real fast. Sorry, a little communication snafu about the. But.
All good.
Where is the thing? Oh, here we go. Apache Beam Meetup 5. Alright, let's see if this works. Alright, come on. Thinking. So I didn't realize that slide deck wasn't the one we were presenting. Going back through here, schemas. Oh. Here we go. So one of the big selling points of Apache Beam is this portability model. So the portability model has two layers of it. There is a portability across languages. So the idea is that you should be able to create a pipeline that contains Beam Java and Beam Python and Beam Go all together, which might sound weird, but it actually enables a lot of scenarios. For instance, JB was talking about IOs they wrote. Well, today you would have to port all those IOs to Python and all those IOs to Go, which means that some languages will always lag behind. If the framework is portable, then you don't have to port them all so quickly because Python can just use the Java IO and it'll just work. Or another example would be a lot of ML libraries today are written in Python. And so people often have this, they're writing in Java, but we want to do stuff in ML, now we have to switch to Python. With portability across languages, you don't have to make that choice. You can just use the Python from inside Java. And then the second part of it is portability across runners. So you should be able to write a pipeline and run it on Cloud Dataflow, run it on Apache Spark, run it on Apache Flink, whichever one you want. So I'll just have a few slides about how this works. I'm not going to do, I think I've already held everyone here long enough, so I'm not going to do a super deep dive into how portability works. But the basic idea is that initially the way Beam worked is everything was monolithic. So you start up a JVM, you had this big giant fat jar which contained the Beam SDK, contained a bunch of runner code that knew how to execute the Beam SDK, And it also contained all the code that you wrote. All the do funds you wrote, all the combined funds or window funds you wrote. The basic idea of portability is to separate these concerns. And effectively, you're splitting things into two components, which by default run in two separate processes. And also by default, we use Docker to manage those two separate processes, although that's not fundamental to the model. So then people may come up with versions of it that don't use Docker, or if you know that they're both in the same language, maybe try to get some efficiency by putting them together in the same process. But there's an SDK process that runs the core SDK code, all those P transforms and the code you wrote, and a runner process, and that's the code that knows how to talk to Flink, and knows how to talk to Spark, or knows how to talk to Dataflow. And in reality, you might have more than one of these. So if you're running, if your pipeline contains Java and Python, you'll probably run two SDK processes, one for Java, one for Python, and then a runner process. So how does this work? At a very, very high level, you have the language-specific SDK. So for instance, the Beam Java SDK. This knows how to construct a pipeline graph. So this is the SDK that you use to write your code today. When you run the Beam pipeline, the output is a graph. And the graph in this new world has some extra constraints it didn't have in the old world. For instance, every transform has to have a well-defined URN. So every do fund you have will be given a URN that uniquely identifies it. That's how Python can call Java and vice versa. Well-known transforms that are part of Beam, like count or sum, will have global URNs that are just defined as part of the model. This is what count always means. There is an API. So today all of our APIs are based off of gRPC, which is an open source RPC system that came out of Google. And this API is called the Runner API, and it's just an API that says, here's how I describe what a pipeline works. Here are the steps in the graph, here are the edges between them, here are the P collections, here are the types of the P collections. Eventually, maybe here are the schemas in it. Then there's another API. So that's the API that just says, here's how to set up the graph. And then the runner will use it, for instance, on Flink. The runner might use it to set up a Flink topology and say, here is what the Flink topology will look like, and actually start the Flink job. Then there's what we call the Fun API. It's not the best name, but the name stuck because it was the Fun API, I think. And this is the API for processing the data. So this is once the job is already started. This is an API for saying, here is data, process it, and then commit the results. So this API is kind of this constant loop of, here is data showing up for some Beam stage. So maybe at a source. It's like, here's new data came from Kafka, process it. And then the language-specific SDK knows how to process it. So if the data is showing up to your do fund, it knows how to run your do fund on the data and figure out the effects that your do fund created, whether it's outputting new data to another do fund, whether it is updating the state of a window, updating a trigger state. And then the SDK harness, which is a little bit of code that runs with SDK, knows how to call back on that API and say, okay, here are the effects of processing that bundle of data in this bit of user code. Maybe the effect is, hey, this other bit of user code with this URN needs to take these outputs and process it, sends it back to this runner. And then, the process keeps repeating. So the outputs of it, might go back to that SDK harness. If what you're outputting is to a do fund in another language, then that runner might send that to that other SDK harness for, in Python or Go. And this at an extremely high level is how this works. The details are much more complicated just because you have to cover the entire Beam surface area in this API. But this is how it works: is this constant back and forth. Get a bundle of data, run it through user code. We call it UDFs, user-defined functions, basically, and then send it back to the runner. And then state and timer, which is part of the Beam API. Side input materialization, knowing when a side input is ready. All of this stuff is handled in the runner. basically means that adding a new language to Beam is much easier than it used to be, because you don't have to know about windowing. You don't have to know about side inputs. You just have to know how to talk to this one much more narrow API, much more low-level API, and as long as you can talk that API, then you can create a new language that works on portability. So where are we? So we have a Flink runner working on portability. There was a legacy Flink runner. It was rewritten to use this new portable API. It's actually been demoed on Python and Go, and both batch and streaming pipelines. This work was done in a branch. So this branch is currently being merged into master. I think it's almost done at this point. There was a whole round of code reviews and some code quality improvements that needed to be done because it was done on a branch with slightly lower standards initially that people were just hacking on. A Spark runner is being designed. There is a legacy Spark runner that works, which is, I believe, what Talend is using right now, and a new Spark runner that is going to be built from the ground up just on this portability API is currently being designed, and probably development on that will start soon. And as far as languages, Python and Go are both based off of the portability API. The Java is usable on the portability API, but I think the default right now on Java is still to use the legacy Beam API. You can set an option and say, I want to use the portability API. That's mostly for reasons of, this is new. We want to make sure we don't suddenly break people who are, turns out there's a bug or a performance regression or something. We was being cautious about, breaking existing use cases. And that was all I had. Any questions? Yes?
What's the plan for moving Java to the portability API within a default as a result?
Yeah, so the first thing is that to move the default for all of Beam of Java to portability API will require discussion on the Beam dev list. So the Beam development committee will have to decide there. For specific runners, so for instance, Google has a data flow runner. That decision may or may not, Beam may decide to move the default of Java to portability, and Dataflow may decide to delay that decision for users of the Dataflow runner for some period of time. So runner authors can also, make independent decisions there. The main things that we have to make sure of is first that all functionality is supported, and that all tests pass. And then there's going to be a question of performance. So we're introducing a new layer, right? What used to be an in-process call is now going over an RPC to another process. So there's some testing to be done, figure out what is the overhead. And if it's too much, we may need to do some optimization of the code to bring it to within some delta before we're willing to make it the default. We don't want people to upgrade to a new version of Beam and be like, wait, my pipeline that used to cost this much now costs 50% more every month.
In your example of decorating the pojos,
Yes.
the schemas, how would you do that in Python or in that schema support? Or is it?
So in Python, so I should have said most of my examples were focused on the Java API, and that's where we've done most of our thoughts. But it's actually much easier to do in Python because Python types are so much more dynamic in Python that you can just always inspect them and figure out what to do. And a lot of the other stuff, like a lot of the dynamic injection of parameters, is much easier to do in Python. In Java, we actually do that with CodeGen. We generate bytecode to do that hookup of parameters in an efficient way. It turned out doing reflection lookups on every single record in a pipeline is being really slow.
So schema support for Python will be right from the start.
Yeah, so schema, the definition of a schema should be part of the portability. So you should be able to set a schema in any language. But that will give you a way of saying using Beam SQL in Python, because Beam SQL today is written in Java. So if Python specifies the schema on a P collection, you can just say apply Beam SQL, and even though Beam SQL is written in Java, and I don't think anybody's currently planning on porting all that code to Python, it should just work. Sorry, what sort of validation?
For example, like saying this field needs to be present or can be new.
Ah.
If I have this, I don't have this other.
Yeah, so schemas actually do support fields can be marked as nullable or not, and actually the SQL dialect we're using supports that natively, although it's currently not hooked up. But yeah, there will be some degree of validation of schemas. Some of it remains to be seen what makes sense in production, because sometimes, if you throw an exception, if you see a missing field, you don't always want your pipeline to come to a screeching halt because one bad record came through. What might make sense more is some sort of dead letter file where a way of saying just fork records that don't pass validation to this other P collection, and then you could decide what to do with it. Maybe write it to a file or drop it on the floor if you want to.
I was thinking for, these use cases now that take a lot of code, like validating ranges and those kind of things. So the schemas might be first step to actually being able to introduce constraints there.
Yeah, for sure. Any other questions? Yeah.
So basically, portability. When we are talking about gRPC based layer.
Yes.
Pretty much. So you are very cautious on when you are saying that you want to test it. Have you seen anything problematic in terms of migrating to this portability layer?
Not really. I mean, it was a long path getting the full feature set supported on portability, because it was basically re-architecting everything in Beam from scratch. So some of that just took a while. We've done some performance tests. So initial performance test on a batch pipeline showed it was about 15% slower, and that was before any performance optimizations had been done. So that was pretty encouraging, because we know there's a lot of low-hanging fruit where we know we're doing things inefficiently. So if things are 15% slower and we know where we're doing things kind of stupidly, we think we can, or at least we hope we can make up that 15%. But we wanted to get everything working before we then turn around and start focusing on performance.
So developers, how long do you think it will take in terms of stabilizing that? Definitely, because if somebody is doing an investment on these kind of things. So should they start doing it in terms of investment, or still they should wait 6 years or 6 months or something?
So
Before serious investment will be done?
Beam Python and Beam Go are already on portability. So it's mostly going to be, we'll have to figure out Beam Python Beam Java on portability. So most investments should, I think, make more sense to happen in the portability world, because 2 out of 3 languages are using that. And the only reason Java doesn't is because there's this existing body of Java users, and you don't want to regress somebody's experience without being very cautious first. It's just an abundance of caution.
And the end user should not be impacted.
Yeah.
I mean, it's completely transparent for you. If you create your pipeline using Java today, whatever you use the portability layer or not, it doesn't really matter. It's more for the runner also.
Yeah.
That's for instance, I started to work on the Spark runner, and it's a huge change for the Spark runner author itself. But for you as an end user, it's completely transparent.
Yeah, unless you're writing a new runner or you're writing a new SDK in a new language, you shouldn't see the difference. All right, cool. Thank you so much for coming out.
Thanks, JB and Ruben, for the great talks. There's only one thing we forgot.
Oh, we forgot to give out
Yeah,
swag.
t-shirts. So are there any t-shirt-worthy questions you guys want to hand some t-shirts out for?
JB, who asked the best questions? Or we could do
We can try.
we could
Yes.
throw it in the air and have people look up for it.
There's girls t-shirts and men t-shirts, so I think, yeah.
Oh, we can ask questions to the guy now.
Sure. Yeah.
Let's try this.
All right, question. 4 t-shirts. Yes.
I've got a question, and it might sound silly if you're sort of really familiar with the computational model and how these things work, but I'm trying to do something that I think is relatively simple,
Yes.
but it seems to be much harder. So we've got essentially an unbounded source
Mm-hmm.
that's coming in, everything is coming in order,
Yep.
and it's watermarked and timestamped on the events, so no out of order events either. And all I want to do is essentially take those bad boys, chunk them into, let's say, 1 minute fixed windows,
Okay.
calculate the total over literally the counts, for example, over those 1 minute fixed windows, easy. And then what I want to do is I want to run at the same time, essentially, a global window that's doing a all-time sort of count or aggregation over the aggregates coming out of the 1 minute windows. So, relatively simple.
Sure.
But the next step is then, what I want to do is I want to rejoin and be in a state where I do a code group by the 1 minute aggregate versus the all-time aggregate that I just had for that point in time. So it's essentially at any point in time I can see for the last minute, let's say it starts from 0. Last minute the count was 1, overall count is 1. Next minute count was 1, overall count is 2. So I literally want to construct a join that gives me the per minute plus the total all time. Now that seems simple, but where it seems to get complicated is I've been trying to sort of get to the bottom of this on the user group as well, is there doesn't seem to be a guarantee with regards to the order in which the 1 minute windows will necessarily arrive in the global window. Therefore, if I put, so the triggers on the global window, I don't have any watermarky type triggers. I've mostly got when an element arrives or that kind of stuff. So that's way easier on a whiteboard to explain. But ultimately, you know, I think I run the risk of, as the 1 minutes arrive in the global window triggers, and I assign them to new windows, that maybe I get minute 1, minute 3, and now I do a total, and the global window emits 1 and 3, and then minute 2 arrives later, but purely because it was in processing time slower, not because it was slower in event time. So the processing time is actually reordering stuff. So I can't have, what it seems that I can't have a consistent way to get my global window aligned with the fixed windows, and that's what I'm just, so I've not been able to actually create this scenario, because on average I run it on Flink Runner and the things work because they work, but I'm not sure whether that's legit a problem or it's just because I don't understand the model well enough.
It's a good question, and I think it would be easier to explain it in detail, but basically you're right that Beam doesn't have order guarantees. For that use case, where you have like a trigger here goes from a key here to a key here, every single runner guarantees order in that use case. Dataflow, Spark, Flink, if you're triggering a key, then trigger 1 will end up here before trigger 2 ends up here. And I think it's something that we probably should actually formalize as part of the Beam model, because, you know, as you've discovered, it's kind of hard. It's kind of hard to reason about things if you don't have that. So an example where people have asked similar questions is, I'm doing a count and I'm triggering it. So maybe it's I'm doing a 6-hour count, but every minute I'm doing the count so far. And then I have a sync that writes it to a key value store. And what you just say, like, okay, I'm going to be writing increasing numbers to the key value store. If things can get, if the triggers get reordered, you're going to write 50 and then you're going to overwrite it with 30. So it turns out that every single runner we have does not do this, so that is in practice guaranteed. We have never actually written it into the Beam model to say this thing is guaranteed. And it's something we probably need to have a discussion in the Beam community and figure out the best way to formalize that, because you're right, it's hard to reason about things.
So it's cool, I don't have to worry about it, because we haven't been able to replicate, but just everything tells me guarantee-wise it can happen, but looking at what I see happening, it doesn't happen.
If I understand your use case properly, I think it will not happen on any of the current runners.
Cool.
It's not officially guaranteed
If
yet.
somebody wants to spend a minute with me afterwards, and it's on the user group, because I just need to get
And maybe a workaround for your use case is instead of using global window and sliding or fixed window, is to use the state API.
So that's another thing that we consider, and this is why, so it's easy if you do the state, because I can buffer and then check, so you'll have a definite guarantee, but I don't want to do that complexity if I have a guarantee, and that's just what I just want to check, is there a guarantee that I will get everything in order? Well, at least when that iterable list that I get, that doesn't need to be in order. I can reshuffle, but I won't get something later.
Right. But the issue is you depend potentially you depend on the runner. Whereas if you use the state API, you are sure of the consistency of your your data.
That's the thing. So the official statement, I suppose, is the API theoretically allows for global window things that are in event time in order, but they can arrive at the global event window and trigger out of order potentially. But we're kind of in luck because the runners at this point do it, and there's no API guarantee unless you build in the stateful do event to buffer for X and then do magic.
But to be honest, I'm willing, I don't know for sure, but I'm willing to bet most users of triggers in Beam just assume things are in order. And so I think we'll probably find that we have to give that guarantee because I think it's an assumption people make without realizing
it's a fair assumption because when we started, we go, oh, of course, and then you start thinking about it, and like, shit, there isn't actually anything stating that this definitely will or will not happen.
So I think that particular thing, most people probably don't think through it as deeply. They write code, it works, and so my prediction is we're going to have to give that guarantee. But I mean, I can't give the guarantee for the Beam community right now. But my prediction is we'll probably have to just because everybody assumes it anyway. There are other forms of sorting that people have asked for as well that are different than that. You know, where you do a group by key and you want to get your iterable back in sorted order. But that's a different story.
I think that
T-shirt,
definitely
yeah.
answers
You
it.
just said the T-shirt.
Alright,
What's
what size are you?
Biggest one you got. Thank you very much.
I don't have a T-shirt cannon, so.
Me neither. Shall we just?
Yeah, I think people.
Oh, there's another question.
I might have another question, but it's for another use case I'm working on.
Okay.
If it's fine.
Yeah.
Okay. The use case is about having an aggregated view in big table.
Okay.
And I've been looking into how we do that. Things, well, increment things are not supported by Dataflow because they don't guarantee that it's going to be executed twice because of these transient failures. Because we will keep retrying. So it would be a feasible solution to have an append-only table, and every time that you have a new event, in a UFM, there's one abstract big table UFM that provides your connection. Do the append, output operation.
Okay.
And after that, you do a range scan and do the aggregation into a new aggregated view.
In the same pipeline?
Yes. After that step. So you guarantee that you have that put operation in place.
Maybe it's kind of.
I mean,
it feels
because,
like
because the use case is, it has to be consistent. You have to avoid.
I mean, it does sound like it's moving outside of the Beam model, like doing an aggregation by scanning a big table instead of doing an aggregation in Beam. And I think it would be tricky to do it consistently. I think you'll find I think there will be a lot of edge cases where if a worker crashed and restarted and did something at the right time, you might end up writing something twice to big table. I think it's possible, but I think it would not be. If you wanted to do something that had no possibility of losing data or duplicating data, it would be a little tricky. My guess, but I would have to look at the details of the problem to say for sure.
And maybe for your use case, you should better split into two pipelines. One that really does the aggregate and push in big table, and notify the other one to trigger and to consume from big table.
Yeah, that's
one that you have appended trigger the
Yes.
other one. Yeah.
I think it would be easier because once when you did the push, you can notify the other pipeline, and so then it starts the aggregation. And I think it would be more consistent and easier to implement. In the same pipeline, it would be a nightmare.
And there are different ways, right? You can send a message to the pipeline. You can create an extra column in big table, which is like a dirty bit. You maybe set the dirty bit whenever there are various ways you can do this sort of pattern if you want to.
But that's also something that I saw with a lot of users, Beam users. They try to achieve all in the one big pipeline. And most of the time, if you just split your pipeline in a chunk of smaller pipelines, it's easier to test and it's easier to do actually. So you can use whatever you want in the middle, Kafka or whatever, to change the pipeline, to do the orchestration of the pipelines, but don't try to put too much in the same pipeline.
When I actually wanted to, when I said in same pipeline, it's like logically speaking.
Oh, okay, yeah. All right.
What's your t-shirt size?
Actually, I made a mistake because I thought that they were available and I just.
Okay, I think
cheater.
I think the rest of the t-shirts are here.
Cheater.
So
people want to
these
take.
are girls' t-shirts, and the rest I'll put here as well. Just grab what you need.
Yeah, I don't. We don't know if we have. Do we have enough for everybody? It might end up being first come first serve.
Yeah. There might be more coming on the next meetup, but just grab some and don't grab another.
Yeah.
There's another one.
Yeah, if you don't get one, come to the next meetup.
And there are stickers at the entrance as well if you want.
Oh yeah. Sticker up your laptop with me.
I'm not sure if they're actually
I don't know with this, it would be, I don't know, an idea to use the unit with the, because with the Java API you can actually test like different so I don't know if it would be a way of overcoming that, like actually using the testing from Java to test the different Python.
It's a good question.
Because yeah, that's one of the things we find, like, you know, if you have to test the pipeline on Python right now, it's not really straightforward.
Yeah, I'm not